All right, a very pleasant morning to you, my students, both Cape and Iscal. I recognize that there are only 7 of you here, 4 Cape and 3 Biscal. This is the absolute last class for the tier of the groups. Um, Cape will have their exam on Monday, Labor Day. And when is the business calculus exam, please?
Sir, on the 27th.
27th. Rockstone in next week.
Yes, sir.
Next week, yeah, that's on like Friday. All right. Well, I mean, to be honest, I will finish off what it is that you will need to finish off with today. The session won't take 4 hours to do what it is that I need to do. This is something that I have done with the Cape students before, and the truth is, it never took long with them. They understood it in a relatively short time. I mean, that's a short time. It's not like 2 classes. I mean, I did it with them in a session. They have a 3-hour session, and I did it in about a short period of time. So I know we can finish off the stuff today, but there are 2 things mainly that I want to do for today. One is to start in a few, get through this piece of what it is that I need to get through, and then use the remainder time to just work some past paper questions. And that I'll ask you all to do for me in terms of maybe those who may have a past paper. And I'm speaking specifically about the BizCal students. Kate, I did say to you yesterday in your group that I want us to have, we will call it now. I want us to have, sorry, I'm distracted. Everywhere in my yard I turn, there is a bird nest, and it's just amazing to see how these birds go and find their little bricks and wicks and branches to make some very intricate, hey, God, great, some intricate nests. And every corner I turn, I'm in a different place now, and I'm watching a bird going into his nest. I'm going to take out the 2 eggs and when them hatch. Anyhow, so I want you BizCal students to find a past paper, ask you to share, and we'll work those questions together. Most of the questions that you get on the BizCal, the Cape students will get it. So the Cape students will benefit from that angle. And then Cape, I know we have exams on Monday. What time Monday is the exam? Monday afternoon, don't?
Yes, sir.
Yeah, Monday afternoon. What I'm trying to do, I did promise you a little marathon. What I'm trying to do is just to focus on the questions that are similar to BizCal today. And then now I will see if I can put a marathon in place for you tomorrow. And which is why I gave you the time last night. Not only because I want you to get some work done upon your own, but it's that I met with the CCCJ students last night who will be preparing for their exams. I did a sensitization session with them. So without further ado, let me just, I congratulated the Cape students already on their SBAs. I mean, it was rough. I should let you know, Cape students, that exams sent me, I sent in the document and they sent me the entries for me to double check, proof check. I have not yet done it because I was preparing for the sensitization session. Sometime today, God's willing, I will do the verification of what they inputted, and then that will be finalized come, well, I know they're going to be there Monday because they have to, physics is Monday morning and math is Monday afternoon. So I'm going to send it off over this weekend so that Monday when they get into office, they will see that stuff. So I'll close off that. And BizCal, I marked your mid-semester, sent it off. Some of you did exceptionally well. Matter of fact, most of you passed it. It's like about one or two of you that didn't do so well. One was borderline, but it's maybe one or two of you that didn't do so well. And I would have hoped that, by the way, before I say what I'm saying, did anybody receive a copy of their mid-semester, the mark mid-semester, Biscal?
Yes, sir.
Okay, because I was hoping that, one or two of those students, or the two students thereabout who never did well, would have at least reached out to me and said, boy, sir, you know, can you explain what I did wrong? But I don't get it. And it's a stage where I want to get my students to develop that level of responsibility and interest. I am sure those who got in the 90s would have looked and said, oh, stupid, why did I make that mistake? Because you'd have seen your errors. I'm hoping that those students who never did well would have also seen their errors and, be able to just move on. But congratulations. What I'm also seeing, and that I'm absolutely loving, that there are some students who have or almost completed their EducaSoft. The Cape students, trust me. Boy, may I tell you, if I were a rich person, we would be having class this morning at one of those 5-star hotels on the North Coast, and the whole of us would be up on the beach with the laptop in our hand and ordering strawberry daiquiri while on the beach, and we'll learn maths together. If only I were rich, because I'm really proud of some of you. Not all students have gotten to the level that they're supposed to be at, but I'm hoping that they will get here. But I'm telling you, there are some of you. No, sir. I'm just really proud of the state that you're at. For Business Cal, there are students who are almost finished, if not finished, because I know when I got a message one day this week, one student had like about 3 pieces. And when I check the class and I reopen stuff for students, I'm seeing where some students are moving. But can I tell you, some students don't start nothing yet for both Cape and Biscal. Don't start one assessment. And guess what? They don't know what to do. But congratulations. Congratulations. All right. Are there any questions before I try getting this thing up?
Yes, sir. Not a question, but a concern. With the EducaSoft, right? Sometimes the system tends to malfunction. And as a result, especially when I'm doing the quiz, it will just blank out and it does automatically mark it. And then sometimes when I go on
say that one more time. Sometimes it what?
The system tends to malfunction. This is something like a pop-up like URL. Yeah, I tend to get that error message a lot, especially when I'm doing a quiz. So as a result, no, it does automatically mark the quiz. We don't even starting to even attempt it.
All right, hold on. Anybody else has that experience? Talk to me, please, because I mean, it's the first time hearing something like this, and
yes, sir.
Oh, so then if you have that same issue? All right, so she's traveling, so she's coming across choppy. But any other student in the class, because it's the first time hearing
Yes,
about
sir, but not with the quiz, so mine also
it happens what for you? All right, she's traveling, she's commuting, so she will come up across choppy. All right, Damian, is the first time hearing about that one?
No, I would have reached out to you already. And what they did, they actually opened it up back for me to
Yeah,
do it.
Yeah. I know there's a fix to it, but I'm saying it's the first. I don't know how widespread. Normally, what I'll say to students is, if there is a break in your internet service.
Yes, sir. That is what happens at times, sir. When
Yeah,
there's
but you can't say the platform malfunction then, because I mean, if the system is using an internet connection. You're not accessing it offline. So if there's a break in your internet service, you are going to have a break in the connectivity. So it's going to shut down or close out. So therefore, that's where I will come into play. So it's not a system error. That's the point I'm trying to make. It's not a system error. So yeah, man, it's not a system error. So if there's a break in your internet service, that's what is going to happen. Okay, let me give you a quick example. Don't even know if this will see what is happening. So anywhere in my house, I can pick up internet access. If I go to the front, to the side, to the back, I can pick up internet access. Well, to one side. Is if I take an extra step to the left beyond the kitchen, I don't get connected to one of the routers. It breaks and then connects to another router, which is my neighbor's router, based on where I live, right? Now, you see, if I'm in this class setting, now having this conversation with you, and I forget that it's going to cut off and connect to the other router, what is going to happen is that I'm going to get an error message for the Zoom class, and it's going to kick me out. And then when I go back into the other area where I have Wi-Fi, it will reconnect. So that's what happens. So if there's a break in the internet service, the system is going to automatically submit the stop. Just contact me. I have no problem. It's an easy fix. Somebody in the class says, "Sir, may I do this something, and something happened to me. Sir, and I was being so, I said, relax yourself. I'll fix it. It's not a problem. Life is not certain. I one day this week, and I'm still in shock, one day this week, I was feeling so overwhelmed with a whole lot of things that are happening at the college, plus my teaching and plus my marking and the whole stuff. And like, for example, I went to bed after 1, and after 5, I was up. And this morning, and I learned that one of my classmates from high school and university died, who was a math teacher in another community college. So like courses like this that I'm teaching, him used to teach it, very nice student, my competitor in high school, and I'm saying to myself, I started reflecting and I said, my God, you go to school for so many years, you study, you do this, you do that, and then all of that knowledge now just going to be eaten by the worms. So the worms have them knowledge there now. And I'm saying to myself, what is man? So life is not certain. So guess what? The internet service now is certain either. Not a problem, Damien. If it happens with another course that you're doing, this is business calculus, you're going to have business statistics in the summer semester. If it also happens with business stats, reach out to your teacher. Easy 1, 2, 3 fix, not a problem. All right. Go ahead.
No, I'm just saying thanks.
Yeah, man. Things are happening, Papa. I'm in church. I'm in church, you see, Damien. And singing a one nice enough, bam, no electricity. Organ now work. The only thing I work is sometimes the organist is playing the organ. And when that happens, she have to jump to the piano, right? And it don't give it the same sort of flair. And they will have to wait until about 5 minutes after there is no power cut for the generator to kick in. And it's when the generator kick in now, she'll go back to the organ, right? So I'm just saying to you, things happen. All right, let's go. I trust that we are, Lord, I should do this. Let me go right here. Let me go right here. I think this works so much better. All right, so we're going to be looking at some multivariable functions, and it's an application of differentiation. Again, some lecturers, like I was talking to Mrs. Hall Francis, who teaches the other business calculus. I think there are 3 business calculus groups. She teaches one, and she says, Mr. Shan, when I'm teaching the business calculus, I just teach differentiation and just finish off differentiation, and then I move to integration. And then now I said, me not do it, say no. Me do it like what the syllabus say. Me do the differentiation, then me do the integration, and then I go back to the applications of the differentiation. And I'm going to tell you why I do it like that. Because when I do the differentiation, I'm able to allow you to percolate the information and to think about the information a little while longer, and then able to do it sometime later. And then when I come back to it, and I can say, oh yes, remember how we do this, as opposed to just doing everything one time. So yes, we're going back to differentiation for this topic. Really not anything too difficult. The only thing there is to it is that it comes with a little bit of flair. And we will see in just a few what flair it is that I'm referring to. But outside of that, I promise you it's not bad. It really isn't bad. I hope you guys are fully registered for exams. Your exam begin on Tuesday. The Cape one begins on Monday. I really hope you guys have not 9 o'clock exam Tuesday that you are not yet registered for. I really hope that that's not any of my students. My students are not the ones who operate like that. All right, just waiting for this system to get over its feelings. It's really been overworked, and I think it's upset with me. So it is trying to say to me that I need a little break. And I'm trying to say to it that I too need a little break. And I keep seeing this message come up. And I'm not in another meeting, but things happen. Final topic, integration. Sorry, multivariable function. You know what I'm going to show you? I'm going to do a 1 or 2 example with you on double integration. I don't expect any of them. I couldn't tell when last I see it on the exam paper, but I'm just going to show you something because I don't want, should in case it comes, you are disadvantaged. So I am going to show you. All right. Disconnect this one. All right, so welcome to the rest of you. Dan, I hope you're feeling much better the rest. I got the message. Well, I don't know if it was a message, but someone said that you weren't well. Hope you're feeling much better, hon. Good to see you. Okay. All right. I'm just trying to clear the chat. Yes. Yes, it will be on Edifor also. I don't know if the exam will be administered on Edifor, but it will be on Edifor also. Amelia, I don't know yet. I know it's not with them in the morning because the youth have to go to church and the youth have to go doing stuff. And then again, now I have evening service too. So we will talk about that. Chip out, okay. All right, good. So I've cleared the chat. Okay. So I've done that. Yes, me too. So we will see what will happen. As I did say, now I was thinking of a little night something, but as I said before, we can. Father God don't want us to give up church to study. I've never done it, and I'm not going to encourage you to do it. And trust me, I've spent a good almost 10 years of studying, consistent studying. So we know that. All righty then. Let me see if I can share the screen. Come on. Yes, but I'm almost sure I opened it before. Why are you not open? So I'm sure I opened it. Of all the Saturday mornings, I normally have my class and then have breakfast after 12 o'clock when class ends. I don't know, maybe because I get up so early this morning, but trust me, sir. Laura, what is on for breakfast? Come on. I mean, what is on for breakfast? Is it toast?
No, sir.
Jeez, I feel like I was eating a cold. Jeez, Tess, Laura, don't have anything. What do you have? See, she's not taking an answer. She's not doing it. All right, I don't know. Students. What is moving?
Sir,
Hmm.
think I marked my paper a little bit strong, you know, sir.
Say it again.
I think I marked my paper a bit strong.
No, not at all. Matter of fact, I look at it and I say, sure. You know, why you do this? I know exactly what you're talking about. I said, why would you do this? But I mean, you did very well. Congratulations. I hope you won't make that mistake again in the final.
I won't say I'll remember the comment and I will not do it again.
I'm telling you, some students when I comment on a paper, I think it's fun when students get back the paper and not just, you know, I was guilty of it. It's when I get back a test paper, the first thing up on the grade. And if the grade, I said, sure, I don't know, man, you have to go through and look at the comments and see, because what I try to, if your exam paper, I try to make comments, even though you may not necessarily see the exam paper, but I write comments on it because sometimes students may want to review. And in the review of the paper, they can see where they would have gone wrong. And, you know, so I often do that, but no, man, you're good, man. I know I'm excited because based on the grades that I'm seeing so far, cumulatively, the mid-semester and the Edicosov grade, I'm seeing some people already at an A. Why is this thing, Jesus? That is not opening. Come against it, Lord. I'm seeing people so far, oh Lord, I think it was like about 4 students, if I'm not mistaken, with A's so far. And I really want those A's to be maintained. So if one of those people with A's so far get a B plus in the final analysis, they have to do over business calculus. I have to do it over because you're supposed to get an A. But yeah, man, proud of you. All right, so this thing is opening up on my part of it, but it's not coming up right here. I don't know what is happening. All right, let me. Give it a silent prayer. All right, so while this thing opens, let me just get your thoughts on a matter, you know, thought-provoking. It is saying that it's opening the multivariable document that I have. Okay, something is flashing. Let me see if it is open. Oh, that's a problem. That's why it's not opening, because I've opened it 2 times. You know what's happening because I've opened it twice. That's the problem. All right. What are your thoughts? I In the last 8 days, we had 8 teachers dying, and on social media, some people are saying that there is a spiritual attack in schools. I went to one school the other day, and I heard one of the believers saying, teacher, when the students were at home, they're online, they're doing all manner of evil on their computers. So them carry the computers from a school now and unleash them something in school. I share a different view. What do you think? Let me tell you my view before I ask what you think. My view is the teacher has had a tumultuous time online. And then somebody will say, but certain things that the students don't have it too. Absolutely. But let me tell you, for me, and I can only speak of my experience. You see, when normally and cave students, I would have met them only 2 times face to face. And the 2 times I met them face to face is not even, I think one time was like about 2 hours and the other time was like about 1 hour. Right? Which would amount about one of the sessions that I would have met with them online. Let me tell you the challenge. For me, I like to read body languages. I like to stand in front of my class. And when I teach it, I'm going to test look up our face and say, should not understand. And then I'll walk around. And my cave students can tell you this. I don't think I sat down in the class when I came to teach, because I was up and down marching through the rows in the class and looking at what students are doing. And some of them were covering their books. And I expect that to happen because I want to see what it is that they're doing. I read body languages. I stood up over them when they're doing the question. These are some of the affective domain that is missing in the online arena. So for me, to make up for that, I get very agitated when students are not talking. Hi, open the mic and talk to me now. Are you understanding? So there are times, sometimes after every 2 sentences, I say, are you understanding? I know why I do that. It's just to make sure that you are there. Just to make sure that you're there. So it requires quite a bit. It takes a lot more, if I were to be very honest, it takes a lot more out of me to do this thing online than it is to do face-to-face. And I'm going to learn another thing. For face-to-face for me, when I normally go to my classes, I'm going to tell you the honest truth. I walk it like about 3 markers, 3 different colors, and I walk with my eraser, and I mean that. And I come to class, and I know I teach multivariable functions, and what I'm going to do is make up some questions out of my head, and I'm going to teach it. I'm doing integration. I do the same thing. The CAPE students can tell you when I was doing differentiation and integration with them in the face-to-face modality, we never walk in a book. We just come and just write up some questions and do the stuff. It's like what you see that is being projected on the screen now. The online medium caused me now to sit down and make up questions and do the solution. So at least, somebody in the class who don't see it, I can send the solution, I can predict. So it requires a whole lot. So what's the point I'm making? I think teachers know, and then because we go back to the face-to-face and so much is required of us, I think some teachers, take it to heart, their blood pressure gone up, then this, that. And then, they just reach their breaking point. And it is so sad. But what are your views? In a few minutes, what are your views before I move on? The system came up. So
Morning, sir. What was the question, please? I just heard you say, what are your views on, and then my internet went.
Is anyone hearing me?
Yes, sir.
You're just hearing you.
Were you hearing me before?
No, sir.
You know, so I'm having a conversation with myself. Clearly. As I said before, I normally use multiple devices, so I had disconnected my cell phone to use a computer, and then this computer just not, I don't know what is happening. And I was trying to share the screen, and then after that, I just see it disconnect. Anybody saw that the screen was trying to be shared?
Yes, sir.
Yeah, and it just disconnect. I don't know what is happening. All right. Father. Right. I think I should just maybe start telling me some stuff first. I'm unable to share the screen. I'm unable to get onto Zoom, even though I'm logged on. Let me just check to see if I got disconnected. Participants. Am I logged on twice? Nope. I am only logged on once. So what has happened is that it has kicked me out from the computer. All right, so it means then that I need to go back in. See, I don't understand. Automatically just come back up. Let me see if I'm seeing myself twice here again now. I'm not seeing myself in the chat twice, but just came back up a while. Unable to join this meeting. Okay, check your network and try again. All right. I may have had a break in my internet access. Damien, unmute, Papa.
Yes, sir.
Right. Come on, is what I was explaining to you earlier?
Yes, sir.
Is exactly what just happened to me. I was logged on the computer because I was sharing, and it can verify I was logged on to the computer because there's a computer I'm sharing my document from, and somebody said that they saw that I was sharing, and all of a sudden it just kicked me out.
Oh, yes, sir.
And then a message came up to say that I was disconnected, and I got disconnected because it would have been that there was a break in my internet service. So
okay,
sorry
sir.
about that. Yeah, so that's what happens, Papa.
Yes, sir. I understand.
Cool. Let's see if I can go back in because I need to share the document from the computer. I don't like sharing from the cell phone or the tablet. But it favors it. I may have to do that because the system just decided that it's not. All right, what should I do? Oh, it's opening up. All right, let me just talk to you about one or two or so. So the multivariable function that we're going to be looking at, as it says multivariable. Multi means more than one, don't. That's a many, all right? But multivariable, it means that you have more than one variable. A single variable function as just single means one. So you have a single variable function. So the CAPE students can tell you that, you know, when I was teaching the topic, I talk about husband and wife and who single from, because multivariable is, and are you alone? The truth of the matter is, if you have, when you're married, you cannot make a decision. Well, stop it, Mr. Shan. You shouldn't make a decision on your own. It should be a decision that both parties will sit and make together. We know that's what should happen, but in the ideal world, husband decides to make him one a choice, wife decides to make her own a choice, And wife said to husband, "Aye, goods, and me make my own money here, so you can't talk to me." And husband will say, "Aye, remember you're not working, so anything you want to me can do," which should not be the case. Should be that both people come together. When you are single, on the other hand, and multivariable function tells you that the husband can say to the wife, "I do not need you," nor the wife to the husband, "I do not need you," just like Corinthians, right? Illustration of the body. So what happens is, when you look at the multivariable function tells us that the husband depends on the wife and the wife depends on the husband. It's when you're single, you don't depend on a soul but yourself. And the multivariable functions will prove that. So when you're single, meaning that you're just X alone or Y alone, when your name is called, we can differentiate you. If your name not called, you can take with yourself because you're a constant. And we know the differential of a constant is 0, right? But when you are a husband and a wife, marriage, and I'm speaking to the wife, the husband is there, but the husband don't need to talk because it's not the husband's turn. And when it is a husband's turn, the wife don't need to talk. She doesn't even listen, right? And in the multivariable functions, you will not be able to speak to both husband and wife at the same time. It's one followed by the other, all right? And you will see as soon as this thing, no, it says not responding. As soon as, oh, but no, but I'm on the phone and you guys are on a second. Okay, all right, let me disconnect. All right, so I am back with you. I'm hoping that I am being heard. Am I being heard?
Yes, sir.
Great. And I'm sharing. Let me know when you're seeing my screen.
Yes, sir.
Nice job. So, as I was saying now, so the husband can say to the wife, say, whatever the situation is, and because the wife also has a voice, and the husband cannot take that voice away from the wife, and vice versa. All right. And I know one or two people may say, "Sir, so you would think," but also it go for the multivariable functions. So we're looking at the first order partial derivatives, and then we're going to be looking at the second order partial derivatives, and then we're going to be looking at the cross order partial derivatives. It's all like big stuff, but it's not big, right? Just big names. Now, I'm going to and how I'm teaching this question, the introduction is what I just gave you. How I'm teaching this question is as it is, just by examples. There's nothing more to it because you already know the foundation, which is our differentiation. So you're going to see something like that. F of xy. F of xy means that it is a function involving x and y. It's a function involving x and y. Then, sir, you can have a function involving x, y, and z. What to stop them? Absolutely. And you can have it with A, B, and C to and D, sir, and E. Absolutely. But for the purpose of this course, for K and for given calculus, we're going to be using the multivariable functions with just x and y, two variable multivariable functions. For another course that I'm teaching now, calculus 2, the students are using x, y, and z, three variables in the multivariable function. So look at the question. F of xy is equal to 4x cubed y squared plus 5y squared minus x to the fourth plus 9xy squared plus 2. It says to evaluate f subscript x of xy and f subscript y of xy. So what that means? It is really asking you to do the differential. So f subscript x is actually differentiating with respect to x, and f subscript y is a differential with respect to y. All right, so let's go. F of xy. Then I have 4x cubed y squared. Now listen to me carefully. One example I'm going to show and done it. Don't blink. All right, never mind. I understand you're in commute. Hear this. You see the x cubed and the y squared, they're married. So why you see that? Because it's being multiplied. Them come together. The x side of the y. You see the 5y squared? Single. Sir, how you know that? It tell you? Yeah, man. Because I just y alone write this up for that term. You recognize, these are terms, So this is one term separated by the operation, positive sign, another. Remember, the operations that separate terms are only plus and minus. So this here is one term separated by this operation, another term. This operator separates this to be one term, another term, another. So this has 5 terms. For the first term, there's a marriage. I see it now, sir, because you have the x and y, the product, so it's like a marriage. Yeah, the one is single. I think I see it now, sir, because it only have the y. Yeah, the one is single. Okay. But the one you're married. Yeah. The one you're not fully developed yet, because it's a constant. All right. So, because one is married, one is single, married, a constant. Watch me. Just as how we use the product rule for differentiation, the first, which is 4x cubed, times the differentiation of the second, which is y squared, plus the second times the differentiation of the first, gives me my same result. On the other hand, though, I am going to show you how it is that I want you to do this differentiation. Watch me. Don't blink. This is it. I am differentiating with respect to x. So it means that I'm having a conversation with x. So y is a constant. I'm differentiating with respect to x. So I'm only interested in dealing with the x. We're not dealing with y now. Y can wait until it's y's turn. Watch me. It means then that my y squared is a constant, as I just said. How you know, sir? Because I'm differentiating with respect to x. It means that y squared is a constant. So because y squared is a constant, and if it's married, I can't throw y out of the house, Because whether or not y contributed to anything, y is still part of the union. So y have to get something. So guess what? Y is a constant, y squared rather is a constant. So I'm going to write back the y squared. See this, so the y squared here, so, or the y squared right here, so. Because I can't throw out y squared. Y squared is a part of the discussion, but I'm not speaking to y squared just yet. All right? The conversation is only with x squared, with x cubed, 4x cubed, because I'm differentiating with respect to x. So when I differentiate 4x cubed, I get what?
12x squared.
Teacher right here, sir? 12x squared. So the differential of this term with respect to x is going to be 12x squared, y squared. You see how easy it is? You don't even have to write it. You can do it in your headspace. Let me say it one more time. I am differentiating with respect to x. Sir, how do you know that? The subscript down here, sir. So it's very important that you write the subscript so you know what term that you're differentiating with respect to. All right? So when I'm differentiating with respect to x, it means that my y is a constant. So the y squared here is going to write back here, so because it's a constant. I don't want anything to do with the y squared, it's a constant. So I put it back right here. So y squared is a boom, come back right here. So I'm only interested in my x. So I'm differentiating now with respect to x. And when I differentiate 4x cubed, I'm going to get 12x squared. So my answer for that first term is going to be 12x squared y squared. Watch me. I'm differentiating with respect to x. This one is single. Huh? You don't have anybody to account for. So because it is single, and I'm differentiating with respect to x, all of this now becomes a constant, and it goes to 0. You notice you're not seeing any of the terms here. Bam, 0. The next one here now, I'm differentiating with respect to x. But this one can stay in the conversation because it's an x term. So when I differentiate negative x to the 4th, I'm going to get negative 4x cubed. See it right here, so negative 4x cubed. Jump to this one now. This one is married. Or you know, sir, it's a product. Or you know, x and y. All right? Multiplying together. So I'm differentiating with respect to x. That means my y squared is a constant, but I cannot throw it out like I did this one. This one is single, so I throw it out. This one is married, so I'm going to speak to the x first, and then I speak to the y after. So because the y squared is a constant, I'm going to write it back. See it here, so the y squared right here, so. And then I'm going to differentiate 9x. When I differentiate 9x, I'm going to get 9. So the answer is going to be 9y squared. And we know from long time that the differential of a constant is equal to 0. So that gone to 0. Boom. And it's done. Ask me your questions. What questions do you have? The topic finished, you know. What questions do you have? Are you seeing it? You're not seeing it? I've done this, somebody. I've done it. Talk to me. Are you hearing me, guys? Anybody hearing me?
Yes, sir.
Yes, sir.
Someone answer me now. Sure. I'm the last person. Talk to me. Are there any questions? Okay, let me ask. Kate, do you have any questions here?
No, sir.
Okay. Business campus, do you have any questions? All right, do me a favor. Since there are no questions.
Sir, can you give me a moment to write what you said?
You want a moment to write what I said?
Yes, sir.
Okay, go ahead. And take a moment. And for those of you who got what I said, so therefore you're not answering me, I'm going to ask you to try the differential with respect to y. So when you finish writing what you're writing, I'm going to ask you to try the differential with respect to y. I just did the differential with respect to x. I want you to try the differential with respect to y for me. And then I'm going to ask you to get it right. Okay? I'm just asking you to try. If you get it right, that is icing on the cake. If you don't get it right, we're just learning the topic. I will go through with it. All right. So I'm going to ask that you all try for me the differential with respect to y. always say, is this difference? Because I know that it keeps it in small. Is this difference always the differential with respect to y?
Yes, sir.
All right, what you get?
I got 12x squared y plus 10y plus 9xy.
All right, that's fine. Say it again, no? Remember, the aim is not to get it right. So go again, say it again. Because I hear some correct stuff in it. You said 12xy?
Sir, I said 12x squared y plus 10y, 9xy.
9xy, all right. So you got this term correctly. You didn't get this term correctly because you never did a multiplication by 2. So you're saying to me 9x, 9xy is supposed to be 18xy. So let us go and see what it is. Let me stop share to get rid of this. All right, let us go. Thanks for your effort. Let us go. Let's go. F subscript y. I am differentiating with respect to y. You see that 4x cube here is a constant. Is a constant because I'm differentiating now with respect to y. So this 4x cube, I'm going to write it back here. So write it back here. So and then now I'm going to differentiate my y squared. I'm going to differentiate y squared. I'm going to get 2y. So when I multiply these together, I'm going to get 4 times 2 is 8. 8x cubed y right here. So boom. I'm differentiating this with respect to y. Oh, but it is a y. So I can differentiate it this time now. So 5 times 2 is 10y. We get that. Very good. This term is x. It's single and it's a constant. I can't differentiate it. It's 0, sir. Very good. This one here is married and I'm differentiating now with respect to y. So this 9x is going to be a constant. So I write the 9x. And when I write the 9x, now I'm going to differentiate my y squared. I'm going to differentiate y squared. I'm going to get 2y. So that's why I get a 2y. And of course, the 2 is a constant. Then when I put it together, 9 times 2 is 18xy. See it now?
So what is it about the negative x to the fourth power?
It's a constant. Why constant? Because I'm differentiating with respect to y and not x. So it's a constant.
Okay, sir, because I got that part, but I included the
x.
Yes.
Yeah. So it's a constant. So you have to know. So that's the only trick, because you see, all that we're doing right here is differentiation. Every single something we're doing right here says differentiation. So what you have to be careful of now is to see what you're differentiating with respect to. You have to have that sort of eye for detail now. That's on a bright people, because only business campus, business campus students on a bright. Because in my lifetime, I don't think I've ever go study accounts. I just see the subject and just read it. And they say, "But sir, accounts not hard." We think it's the hardest subject. So that's why I'm saying to you, any business calculus student, any business student shouldn't feel a math course, because math is easier than accounts. When I say easier than accounts, it pales into comparison. On the bright, we used to look at costing and balance book and what? No, sir. Things are hard something. So just like when you have an eye for detail, which one to put under debit and credit, I think that's what we call it, it's the same eye for detail, which one you're differentiating with respect to. All right. Having said that, and I'm going to project one other one, and I'm going to ask you to do that. I'm going to give you 3 minutes. I'm stepping away. 3 minutes, and do that one for me, please. Both for x, I'm going to give you 4 minutes, because I want to find the differential with respect to x first, and then the differential with respect to y. Thanks. All right, all right. Let me see which grade business calculus student. I know the Cape students know this. I want to see if it's going to be Dana, Laurelie. Is it going to be Tess? Is it going to be Sachelle? Is it going to be Shakir? Is it going to be a Cape student who can come on? Who is it anyway? Let me hear. Who? Remember when you speak to Sir, yeah, go through Sashi D. Yeah, run it.
To with the differential with respect to x,
Mhm.
2y plus 10x y take away 6y squared.
That's what you say?
Yes, sir.
Congratulations, Sashi D.
And with respect to
I'll give that chance to do that. Don't unmute. Don't mute yourself just yet. I just need to ask others. The rest of you, are you agreeing with Sash and Teacher Shan?
yes, sir.
Nice, very good. Woo-hoo. All right. Is there any of the business calculus students that don't? Sorry, name again. Damian, unmute and talk to the teacher. Gotcha. Damian not here? No, you are not. Let's see. So we had the man them just disappear, so? All right. Go ahead. Go against that. What is the differential with respect to y?
2x plus 5x squared take away 12xy.
Why, Sash? You know you eat breakfast this morning? Trust me, Sash. You like it? Very nice. Kate, let me touch base with you. When did you get this down?
Yes, sir.
Right. Is there any Cape student that didn't get it? Speak up. Speak truthfully. Is there any Cape student that didn't get this? Matthew, you got it? Tatiana, you got it? Tanisa, you got it? Tariq, you got it?
Yes, sir, I got it.
Okay.
Yes, sir.
Because
Yes.
you know the teacher did come shake out your lunch money so you can go eat some nice gungo pea soup. All right, very nice. Love the sound of it. All right. So let me see now. Who are we? Diana. You see, because I know the Cape students and know this already, you know. So
Yes, sir.
they are just doing this
That's
for
what I
revision.
thought.
No, man, hold on, no, don't rush me so much. Don't rush me. I am saying, Diana, the next question are yours. All right. So the rest of you going to do it, you know. But Didi, you can do this one for me. Anybody call it Didi, Diana?
Yeah.
All right. So, Didi, this one is yours. The rest of you, run it. 4 more minutes. Didi, you ready for teacher?
Well, so I'm gonna make a choice, you know.
No, I don't care about that. I just want to give it a try. Go ahead, honey bunches.
Okay, so make for the x,
Mm-hmm.
I got 12xy to the 3 plus 8xy to the 3, 10 plus 2y.
All right. Is she correct?
No, sir.
No.
Hold on,
Because
why did I write this?
I'm going to tell you why.
Why?
Matter of fact, let me ask somebody. Don't worry about it. Let me ask somebody. Tell me what error she performed.
Sir, she said 8x.
She said
That's
8x.
what, yeah, I
Right.
heard that.
Right. Thank you, Natty D. Yes. Remember, you know, you're differentiating 8x. So when you differentiate 8x, you're supposed to get 8. Talk truth.
Oh yes, sir. Me just see.
Yeah, man.
Okay.
So I think your first term was correct, 12xy cubed. You got that down.
Yeah.
Yeah,
Yeah.
man. That was correct. And I said to myself, yes, thank you, Jesus. And then when I hear say 8x, I said, oh no, she
Yeah.
never
Miss
differentiated. All right.
right.
But
Yes, sir.
you also made another mistake though. Did you get a negative 10y? X, 10xy?
Sir, me never said a y there. Said that
The
5x there. So I actually have
didn't do that term.
negative 10y.
All right. Negative 10x.
X, yes, because I didn't see the y.
You
Yeah.
didn't say the y, right. So that, and then no, you also put back the 2y.
Yeah.
The 2y is a constant because it differentiates in respect to
For the x, yeah.
right. So it's a constant. All right. All right. So guess what? Because I made that error right there, so I'm going to give you enough time to fix the other one, the f subscript y. But I'm going to ask somebody to help me out with the f subscript y, and then I'll come back to you with one piece more of the other question. All right? That's all right? Okay. Who wants to help DD with f subscript y? Anybody? Cape or Miss Cal? Go, Casey.
So I have 18x.
Go ahead. All right. So two of you were trying to say something, and then both of you disappear. Who is going to speak? Is it Cassano or is it
I have
okay.
18x squared y squared 2xy cube minus 5x squared plus say that alone,
Plus
sir.
2.
Plus 2. So plus 2, no?
Plus 2.
Sure.
So I'm never sure about that, sir.
You just a habit. Me not even breathe, but hold my breath, and I said, we should say the plus 2, no? Sure. You want to kill a teacher? The teacher holding breath. Very nice.
What's so funny? Don't me get the FY right.
You get it right?
Yeah, that may have.
Very nice. Very nice. Very nice. So guess what? DD, I know you're learning. Very nice. Kes, and Cassandra, very nice. Tess, thank you for coming out and bailing out. I'll Tess have to say, good, say 2 no? Sure. So I can say Tess, let me say Tess, I push her in the back and say 2 no, my girl, say 2 no. Very nice. I'm going to give you, let me ask a question first. Let me not ask a question. I know why. Let me give you yet another one. And then what I'm going to do now is to look at the second order partial derivatives. Ooh, that one is nice. Who's going to do this one for teacher? I'm going to call upon Miss Allwood. I'm going to call upon Miss Allwood. Check here. Miss Allwood. This one I yearns. All right? And we're going to play tag. So if you don't get something right, you're going to call upon one of your classmates. Yeah? All right, let's go. I'll give you 4 more minutes. 2 minutes for the f subscript y, 2 minutes for the s subscript x. Start. On the mark, get set, go. Shakiboo. Ready, blow. Ready
Sir,
now.
mentally understood, sir. Me stuck on the 1 year, sir.
Shaki, don't do that to me, man. All
Sir,
right.
honestly, sir, when me see it myself, no man, why you follow one them, sir, for choose me, sir.
All right, never mind, never mind. Just what may happen. Laura, so Shaki just asked a while ago if you can help her out because she's stuck. Come, Laura, come, help out with friend.
Yes, sir. Right. With respect to x, I got 5x to the 4th y cubed minus y to the 5th minus y.
Is she correct, guys?
Yes, sir.
To the T,
Yes,
to the
yeah.
T, to the
Okay.
T. All right, come, Laura, boo. Ready? F subscript y.
I got 3x to the 5th y squared minus 5x y to the 4th minus x.
Is she correct again?
No, sir. +1.
Plus one.
Plus one.
Plus one. Because remember, this
Okay.
load some y out here saying, no, you have to differentiate this y to get the plus one. Yes.
Oh my God. Me, I look on it as a constant, sir. I didn't see it.
Yeah. But guess what? Very good. I'm going to pause and say something. And I don't care who wants to vex. If you're vexed, tell it to Jesus. I can say 100% without a shadow of a doubt in my mind that this online business can work. This is a concept that takes me a while when I'm in the face-to-face setting. And I'm telling you, when I taught my CAPE students, in a jiffy they got it. In a jiffy they got it. And look at this. In a jiffy you two are getting it. I don't care what nobody wants to say. Take it to Jesus. Effective teaching and learning can happen in this space, and I'm seeing it. I'm seeing it. I mean, somebody else have to prove it otherwise to me. Very nice. Very, very, very nice. Hear my question now. Who is struggling? Because I want to move on from the first order now to the second order. So before I move on to the second order,
I have a
go right ahead. Go right ahead.
I put the +1 right here.
Because this y is single, but I'm differentiating with respect to y. So I have to differentiate it. If I were differentiating with respect to x, it would be a constant. Yeah, man. But because I'm differentiating with respect to y. All right. Thanks, guests, for that answer. Are there any other questions?
Question there. Kind of. Are you hearing me, sir?
No. Say it again, honey. Cassandra?
Sir, a derivative from morning, sir.
Anybody pick up what she's saying?
No, sir.
Sir,
So she's asking if this is what we've been doing from.
Oh yeah. This is what we've been doing for money, yeah, man. This is a new topic. It's application to differentiation. So we have been differentiating for talk truth about the last 2 months we started differentiation, right? And I paused on differentiation. I went back to it for single variable function, and I'm now back with it finally for the multivariable function. So yeah, it's an application to differentiation. All right. So this is what is going to happen now. So you will see that I have many more examples to give you. I'm leaving those, well, not many actually, just one more example. But I can generate more examples for that. I'm now interested in moving to the second order partial derivative. The second order partial derivative, right? I'm going to also look at the cross order partial derivative, but I'm going to be looking at the second order partial derivative because I'm getting somewhere. I'm getting somewhere. I remember when I was doing this, I made a bet with the CAPE students who said, "Sir, you think you can believe, sir? Jesus, sir, tell us it's something easy. And when you check us up, it's hard. Shanti, am I speaking the truth?"
Yes, sir.
But was it difficult?
No, sir.
And I proved them wrong. Shanti, and Tani, and watch it, man. Watch it. You're not ready for comedy, man. It's not when I should quiet. You're not ready for comedy yet, man. Watch and see. And I surprised them. They said, "Sir, are they, sir?" Yup. He said, "Okay." right? So sometimes, we have to prove the students wrong. Let us go with this one. I have my answers here because I want to show you what is happening. I want to show. No, Mr. Shani can't do that. Don't do that. Because in order for you to do the second order partial derivative, you must first do the first order partial derivative. So press pause. Sir, what is second order partial derivative? It's by finding the second derivative. So in order to find the second derivative, as I would have told you before, you have to find the first derivative and then find the second derivative thereafter. So, but we never did no second derivative before. Not true. When we looked at stationary functions, in particular, to classify the nature of those stationary points, we had to find the second derivative. You know why? Because Sir taught you two methods, and it is so funny that business calculus and K said them don't like my graphical method. That's what you said to me indirectly, right? Because I can hear you, and most of you using the second derivative method, which is not a problem to me. So we have done second derivatives. So you know how to do second derivatives. All right, let's go. Do me a favor. I want you, all of you, because in order, as I said before, to do the second order partial derivative, you have to first do the first order partial derivative. So I want you to go ahead and do the first order partial derivative for me of that function, meaning you're going to find f subscript x of xy and f subscript y of xy. Let me just point out something to you. I don't think I did it. You see, when we talk about first order partial derivative, it means there's only one of the variables that will be under here, so just x. So I can tell you that this is the first order partial derivative with respect to x. This is the first order partial derivative with respect to y. Watch me now. When I move into my second order partial derivative, you notice I have xx. So the mere fact that I have xx, it means that I'm into the second order partial derivative with respect to x. And this is the second order partial derivative with respect to y. Oh, you know second, sir? Because come, let us count. First, second, two something under here, so we'll call it second. And two more under here, so we'll call it second. All right? So do me a favor. In 3 minutes, find f subscript x and f subscript y on the mark. That's it. Good to go.
Sir.
Yes, Matthew.
For the second, that's something the way up, sir. 2 times I differentiated.
Very good. Excellent, sir. Yeah.
I'm just.
Cool. Everybody finished that so far? First partial derivative?
Yes, sir.
Yes, sir.
All right, cool. I'm just going to show them. 10 minutes to get them right.
Yes, sir.
Yes,
Very good,
sir.
Shanti. Very good,
Yes,
Lord.
sir.
Yes, very good, Des.
No,
Very
sir.
nice.
I'm kind of sort of
And I love your honesty.
sir, just go on. Look at this one. Skip it.
Jesus. This is 24 and 12. That's 36. 36 and 12. That's 48. 48 and 3. 51 hours before she had to do her exam, Jesus. And Natty B, I got going with the same. Natty, answer the question. And don't make the young teacher fall out. Where you went wrong?
Sir, I'm just come and I write up the question, so I never actually do it.
Oh, so tell me that they know.
But me think more than get it right, but I never actually do it.
Oh, so the way you say it, Natty, me think say you try the question and you don't get nothing close to this. Oh, that puts a different twist to it. All right, so I will allow this to stay here while you go and work on it, while I give the other students another task to do for me. Other students, here are your other tasks. You are now going to find the second partial derivative. What's strange about an example? I mean, I don't know, now you are going to do it. The second order partial derivative with respect to x, the second order partial derivative with respect to y. Sir, how do we do that? Thank you for asking. So you have the first order partial derivative of x already here. You're going to differentiate this function one more time with x to get the xx. I'm going to retry here, so you're going to differentiate this one more time with respect to y to get the yy. Understood?
Yes, sir.
Run it. My people, my people, my people, my people. Let me hear.
Done, sir.
Ah, cool, nice. You know, I don't, Dinah, oh, Damien just come out of class and I say nothing, sir. But you may not go and go.
So I'm internet.
Okay, all right. So you know, so you have to go learn it for teaching, don't? For the last classes, you know. I heard that. All right. All right, cool. You know what I'm gonna do? I just gonna project that and ask if everybody get that.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Is there anybody who did not get it? Just be very honest with you. At the last class, we're not gonna even come back next week. Next week, this time, we're on vacation. You never get it, no problem. I love the honesty. Let us go. Let us go. So if we're given the function f subscript x of xy, f subscript x of xy, and then we are differentiating with respect to x. The same thing we did for the first order partial derivative is the same thing we're going to do for the second order partial derivative. What do you mean by that, sir? I am differentiating with respect to x. I'm going to keep my x, my y constant, and differentiate my x. Watch this. My y constant, that means my y squared is going to be written back. See yourself? Y squared. And differentiate the x. When I differentiate 12x squared, I'm going to get 24x. See yourself? 24x. So the term is going to be 24xy squared. I'm differentiating this with respect to x. It's single and it's x, so we can work with it. Negative 12x cubed, squared. See right here, so negative 12x squared. This one here, it is single, sir, and it is a different something. So it goes to 0. Kesana, you see?
Yes.
Nice job, nice job. All right. And then now, this is what I got for f of yy. Oh, second order partial derivative. All right.
Sir, you have to go over the ln ex raised to whatever one then.
Yeah, when we do the past because then we see them there. All right, and the second order partial derivative now is going to be that. Let me know if you got that.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Oh, Didi, me hear that, you know. You better didn't get it because I forgot to teach Damien. Oh, very nice. Very, very, very nice. All right. Now, you know how to roll.
Wait, sir, isn't that supposed to be x?
Yes, sir.
What's this one?
Sir?
18x? 18x.
Yeah.
I put that there to see if you're paying attention. It's supposed to be 18x.
No, sir, you didn't.
You see? Okay, the rest of you. That's Tanil. That's the same one who said to me when I was teaching something that Mr. Sir, I'm going to say it easy and it's hard. All right, yeah, it's supposed to be X. I don't know what happened right here. Thank you, Tantan. 10 more. Yes, honey bunches are hearing it. Go ahead.
I got it wrong because I had 8x cubed plus 18x there because when I do the mega part, I get 10 and then may I say the differential of a constant is 0, so I never put the 10.
Oh, but I'm differentiating with respect to y. No, that concept is correct. Yeah, man, you're fully right when you say the differential of a constant is 0, yes. But in this case, y wasn't the constant, it was x. Yeah, man. Very good, very nice. Alrighty then. Thank you. And listen, this is what happens, you know, when teacher preparing these things, the truth of the matter is these things, you know, teacher can make mistakes. And one of the things that I love when I make a mistake and my students are able to point it out. I don't feel like other teachers. The other day I was doing something in class and I made a mistake. Matthew asked a question and I answered Matthew. Sleep in my eye, I answered Matthew. But you may answer Matthew a while ago. and I have to correct myself. So learning, and one of the reasons why I like making mistakes in class, sometimes I make some deliberate mistakes, and sometimes the mistakes are genuine. But why I like to make mistakes is that I want my students to recognize that I am also real. And when I make the mistake, I bounce back and move on. And that's what I want you to do also. All right? So do me a favor now. I'll give you another one and I'll ask you to find fxx, fyy. I'm going somewhere with this, because in order to find fxx, you have to find f subscript x first. And in order to find fyy, you have to find f subscript y first. So in order to do these two something of 4 different calculations, you're not going to do. I'm going somewhere. 4 minutes. I'm giving you a minute each now. Thank you.
I'm projecting my f of x and f of y and tell me if you agree with those. Do you?
Yes, sir.
Yes, sir.
Good job.
Yes, sir.
Have you finished the second portion derivative already? Second order?
Yes, sir.
Okay.
Yes,
And,
Yes, sir.
and I'm doing that. Agree?
Yes, sir.
Woohoo!
Yes.
Yes.
sir.
Yes, nice.
Yes, sir.
Sir.
Yes, please. I hear you.
All right. Is it a case where, all right, for me, when I did fx, I did y. Sorry.
No, okay. Yeah, I hear. Let me preempt you. And if I'm wrong, tell me, say, no, sir, you're wrong. What Laurie Boo was saying to me, sir, you know what I did? I did f subscript x, and then I just said, sure, yeah, I'm just going to do xx. And then I do f subscript y, and then I do y. Is that what I just said, Laura Lou?
Yes, sir.
Yeah, man, sweetheart. Very nice. Proud of you. Proud of you. Proud of you. Yeah, man. Very nice. And I will show you something a little later on, Laura, that you can say, oh, that means we did right on time. Very nice. Very nice from countries. Very nice. You know, as I said that, you know, I am laughing to myself because I was in a meeting and recently, and some staff member attacked me and said, I cannot speak to students like that. Hum and boo and then something there. And then I said to myself, what? I said, so let me ask a question now. Tyreek and Matthew and the rest of the guys here, when they're calling the pops and sons, do you feel offended by it? We just want to know.
No, sir.
No. All right. Matthew, how you feel? Yeah?
My next teacher comes too.
You have another teacher who's awesome. I'm not the only one. All right.
It's a maths teacher too. Like
a
maths teacher thing.
Lord, so if I saw the maths teacher, them stay then. All right. Let me ask the girls them know. So when I call no hon and dearest, can I have a problem with it? Let me know, you know, because I mean it's something.
No, sir.
No, sir.
No, sir. Tell them to move and go away.
I love you, Tati. I love you. No, let me tell you something, man. In the meeting, I sat down and I swallowed hard because I'm saying to myself, you know, God put a bridle on my tongue because one thing I can tell you, nobody gets between me and my students. And you know, God never leaves his people without a witness. And I'm going to tell you why. The president of the student union was in the meeting. And the president of the student union said, I need to say something. Mr. Shan has taught me several courses. And I saw Mr. Shan talk, and Mr. Shan get on with the whole I'm student then. And you know, I said, boy, thanks for that, but the damage is already done because by the time I feel away, I'm not lie to you. And by the time I left the meeting and the other students who were in the meeting, it was like almost a disciplinary meeting. And then I was being disciplined in the meeting because I was talking to the students and using my same jargon. No, they're all female students. And by the time I came out of that room, some other students came, past students of mine came, you know, and you're supposed to say, they are fourth-year students now. I mean, I say past students because I taught them in the associate degree program. They're wrapping up their fourth year now in the program. They're doing some expeditions on campus. And they just come and they're all over me, and I'm saying to myself, Hon, how you do? And the student says, sir, we recognize that this is how you speak, and I'm going to tell you straight up. I don't agree with the person who said it because I don't have a problem. And I'm saying, you know, if Laura is drinking a bottle of water, and me not like Laura, me not like her because me and her have something, me just say, watch her drink water. Drinking water should not affect me, but because me and Laura have a beef, it is going to affect me. And you know, sometimes we just need to let go and let God. I have been working on it since Thursday of this week when I was accused. And then, just like what I talked to you, some other students, and say, sir, this is who you are, and guess what? You're better than many of them, how you interact with the students, don't change. And it gives me the sort of encouragement to say, you know what? To heck with that person. I'll just continue doing what I'm doing. But bless you. I thank you for the reassurance. And I'm so happy that another math teacher is like that. All right. Put that aside. Put that aside. We're going to do, let's up your heart, sweetie. See that? we're going to do another one because you see, after this one, if everybody get this one, the third example, I'm not going to do any more example, and let's move into the third part of this question business here. So see one more here. I've given you 2 minutes. No, this one is longer. I give you 4 minutes to do this one. On your mark, get set, go.
Yes, sir.
Very nice. You finished your second order partial derivative already too? Or I need another minute? Forgive me. My gardener is sorry, my gardener is here and he is working. Forgive me. No. Tell me if I got the answer.
Yes, sir.
Yes, sir.
Very nice, very nice, very nice, very nice, very nice, very nice. Is there anyone who is struggling with this so far? Because I'm moving into the final stage of the differentiation now. The final stage of the differentiation is to do this, the cross order partial derivative. The final stage is to look at the cross order partial derivative. So, I'm not going to leave at the point, so I'm going to ask you, am I able to do the cross order partial derivative now? Or is there a question or questions that I need to ask? All right, good. So I'm going to be moving into the cross order partial derivatives. I have example 4, example 5, example 6. No, that example 5. So I have 2 more examples there for you to look at for me. Laura Boo, this is it. Remember, you asked a question, sir, am I able to just do the f of x first and the f of together? See, sir, did them right here, so you were right on target. That's why I stopped you before we even finished, because I knew where you're going. So you are on target right here, because that's exactly what sir did. Just did the f of x together and then the f of y together. All right. So 1 minute. So let's go right here. So we're looking at the cross order partial derivatives now. Now, in order for me to do the cross order partial derivatives, there are some steps that I must follow. The cross order partial derivative now. So you notice I'm building. So when I looked at the first order partial derivatives, I have only 2 calculations to do: f subscript x, f subscript y. When I'm looking at the second order partial derivatives, I will have to go ahead and find the first order partial derivative, and then do the second order partial derivative. In this here case now, to find the cross order partial derivative, the second order partial derivative, I will have to go ahead and do some more calculations. So what I want you to do is, for practice, I want you to find the first and second order first and second order partial derivatives for me here. So that means you can do 4 calculations: f subscript x, f subscript xx, f subscript y, f subscript yy. And then I am going to come and show you how to do the cross order partial derivatives, and that will take us into the end of that section. All right. So do those 4 calculations for me in 4 minutes. Agreed with that?
Yes, sir.
Good job. Very nice, students. I'm going to hurry up now. In another 20 minutes, I want to finish off this so we can start finding some papers. I'm going to ask the business calc students to see if we can find some past papers for me. Most of the questions on the business calc, CAPE students are also doing them, so they will also benefit from this exercise. I will need to the CAPE students to deal with areas that are not on your syllabus business calculus. So in the meantime, if you can find a paper, just keep it close by. I will stop share, ask you to share, and we'll work some past papers. All right. F subscript y and yy. Tell me if you agree with those two.
Yes, sir.
Yes, sir.
Very nice. Now, we need to extend the conversation now to the cross-order partial derivative.
So it's supposed to be 16y.
Thank you, honey. Let me just first order partial derivative and second order partial derivative. All right, so you're saying this is supposed to be 16y? For which one? For the differential of f of y? It's supposed to be 16.
Oh, yes, sir. Yes, sir.
Right, that goes to 0. Differentiate with respect to y, so it's going to be negative 24xy. And then, yeah, it's supposed to be 16. All right, so recall that you must use the first derivatives of the original functions to evaluate the following. Now, this is a cross-order partial derivative. Cross-order partial derivative. And I'm saying to you, we must use the first derivatives of the original function to evaluate the cross-order partial derivative. We're talking about cross-order partial derivatives, sir? Thanks for asking. The cross-order partial derivatives, it means that I'm going to find f of xy and f of yx. So we'll call it cross-order. The x and the y, then the y and the x. So the cross-order partial derivative is me finding f of xy and then f of yx. So let us go. Look at what is happening. It says, you must use the first derivatives of the original function to evaluate the following. So here we're not using f of xx and f of yy. We're not interested in those just yet. We're going to be using f subscript x and cross order it. Meaning, in order to find the cross order partial derivative, I'm going to be using f subscript x and then differentiate it with respect to y in order to get f subscript xy, right? So therefore, I'm going to be using this function and differentiate this function with respect to y in order to get xy. So work with me. When I differentiate here with respect to y, it means that my 12x is a constant, and I'm differentiating y. The differential of y is 1. So 12x times 1 is going to be 12x. See it right here, so? Down here, so I get my 12x. Next term, differentiating with respect to y, is a y, so I'm going to differentiate it. 3 times negative 4 is negative 12. Negative 12y squared. See here, so? Negative 12y squared. And when I differentiate this one, when I differentiate this y, I'm going to get 1. All right? So that's how we do the cross-order partial derivative. The cross-order partial derivative of f of xy, I have to first use f of x, differentiate it with respect to y in order to get f of xy. Watch me now. In order for me to get f of yx, I have to use f subscript y and then differentiate it with respect to x. We'll mix it up. I'll mix it up now. This is you having rice for the last 3 days of cooked. And the other day say, no, I have enough rice, but now cook it. You throw some soy sauce for it and have some chicken, some curry chicken and some fried chicken. And so let's call it again, brown stew chicken, and say, watch this. And you're going to cut up and chop up all of them and you're going to get fried rice. You're mixing it up, one pot. Same thing within right here, so mixing it up. So f subscript y, and you're differentiating it with respect to x. So this is it. I'm differentiating with respect to x now to get f of yx. When I differentiate here, 2 times 6 is 12, so I'm going to get 12x. See it right on here, so? And when I differentiate this piece here with respect to x, my y squared is constant, so I'll hold that one side. When I differentiate my negative 12x, I'm going to get negative 12, so I'm going to get negative 12y squared. See it right here, so? To 12y squared. And when I differentiate 16 with respect to x, sir, that's a constant, it's 0. True. And when I differentiate x, I'm going to get 1. And bam, my f of yx is this, and my f of xy, rubbish. My f of xy is this, and my f of yx is that. Tell me if you see and if you agree. And if there's any question that you want to ask me.
Sir, I don't properly digest it, but I think I will get it.
Fair enough. But is there any other question? Are you seeing something that you want to ask me about? Maybe not yet. Maybe not yet. As I said before, I'm giving you these questions because I say every time I give you the question like now to do the cross-order partial derivative, I want you to work f subscript x, f subscript xx, f subscript y, f subscript yy, and then now we're going to find f subscript xy and f subscript yx. What's the point I'm making? Every single time you get a question on multivariable function, there are 6 calculations that you must do. And you see, for the CAPE students, they may get more 4 marks, you know, or 3 marks, but they may ask them to calculate only 2 or 3 or something. You see, for the business calculus students, 6 marks, that's enough. And 6 marks are enough marks. So you know, after the only for work, I get 6 marks. No, send it down. So this question, example 2, what I want you to do for me is to find f subscript x, 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 y, 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 then you can move into your x, y, and y, x. I'm teaching you like that because every time you see the question, whether or not you understand what the question is asking, just go ahead and do these differentiations. You will get marks for that. And then now I'm going to teach the last day to get piece. And my aim is 10:30. My aim is by 11 o'clock. We're finished this. I can spend an hour and run some past paper with you. All right, so do me a favor. On the mark, get set, go. You get this one, we move on. Are you with me for those first order and second order partial derivatives?
Yes, sir.
Very nice. Very nice. Very, very, very nice. All right. Anybody has completed the cross order partial derivatives?
Working on it, sir.
All right,
Yes.
cool. All right, good. So those who are working, give you 1 more minute. Those who finish work, let's look over for 1 more minute, please. 1 more minute.
Sorry, you're muted.
All right, thank you. So everybody got the cross order partial derivatives correct?
Yes, sir.
All right. So so CAPE students, I don't want you to ask me any question. This question is not for you, CAPE students. Business calculus students, is there something that you want to ask me now?
I said, sir, for the X, Y, I had a +6 at the end.
All right, you want to just double check that one to see if you should have that +6 at the end. Is it an error on your part or is it an error on my part? While you double check that for me, let me ask a question specifically to the business calculus because the CAPE students know this. Is there any other question that the business calculus students want to ask me? Okay.
Sir.
Mm-hmm.
Alright. To get the COPD, put that. You use f of x, the first derivative, sir. Yes.
And find it with respect to y, yeah.
With respect to y, and for this one,
you use f subscript y to find and then differentiate it with respect to x, yeah. Okay, but Laura, there's another question I want you to ask me. Ask me now. Is there anybody that sees another question there that is staring right into your face? The Cape students know him. Who want you to ask me?
It's not a question, sir, but I just realized the answers are the same.
Very good. Woo! I had to squeeze that out of you, Laura Boo. Sure. Yes.
Yes, you did, sir.
So every single time, and so I was trying to get that out of you from up here. So when we did this, I got this answer. But hold on, this sir, I just same thing again. I said, no, man, no, say to them because you know, really and truly, I love to do discovery teaching. I mean, engage in discovery teaching and learning. So I teach you something, and I want you to discover it on your own. But sometimes the time not permit us to do them wonderful, nice teaching something there. But yeah, man, every time you do your cross-order partial derivatives, you are going to get the same thing. Now, hear me out. This is a secret. You see, when you do your cross-order partial derivative, your f subscript xy and the f subscript yx, and it's what it works out to be the same something, it tells you that you know, say your f subscript x, 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 y, y, y are correct. You see, when you do them cross-order partial derivatives, so, and you get two other answer being two different something, I would have said to you, press pause, not gonna further. Double check your answer because them two something if they're not right, is indicative that something is off. Trust me. But yes, they will always come out to be the same thing. Very, very, very nice. All right. This one is for the road. I'm giving you this one for the road. And I said, yeah, yes, you're going to use the function in x to evaluate this with respect to y, right? I will just explain that. But I'm giving you this one for the road. That one for the road, just to see if you are seeing what is happening there. So I give you 5 minutes to just finish out that one quickly time for me, because I need to do the other stuff. I'm gonna have about 18 minutes left to just do the last part. So I'm at the last part. Let me just recap something quickly. The first part is to find the FOPD, the first order partial derivative. Then the second part was to find the SOPD, the second order partial derivative. We'll look at the third part to find the COPD, the cross order partial derivative. And then the next part is soon come. 4 parts to this question. And if you understand the first 3 parts, the fourth part is going to be as easy as 1, 2, 3. Start for me, please. Have you completed the first order partial derivative?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right, so I'm projecting the answer for the first order partial derivative. What about, and I did the second order partial derivative also?
Yes, sir.
Yes, sir.
All right, good. Now, have you completed the cross order partial derivative?
Sir, doing that now.
All right, then 1 minute more.
Yes, sir.
Finish, sir.
Yes, Canton, I heard when you said that you finished. That's my cross order partial derivative. Agree with it?
Got that too.
You got the cross order partial derivative?
Yes.
Yes,
Okay.
sir.
Sir.
All right, good job. All
Yes,
right, very nice. I'm going to project one last one in the meantime. So see that one there, start it for me, please. One last one before I move into the last piece. All right. Tell me that you finish now. Finish?
Yes, sir.
Cool.
Yes, sir.
All right. Let me see what is happening here. Tell me if you agree with that, please. Sounds like nobody agrees.
Yes, sir. Check it.
Agree.
Nice. Okay. So check, check and cross and check and check and check and check and check. And then now we will move into the last part.
Agree, sir.
Nice.
Yes, sir. I agree.
Very
Yes,
nice.
sir.
Very nice. Very nice. Very nice. Didi, how you stay? Didi, you never see Africa. Learning for
Good man, sir.
blow. Oh, and them start to be like it though. John, no honey bunches of them. They taught them in love. All right, nice. Okay. All right. So thank you guys for really understanding. Really, 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 I'm excited. Matter of fact, you said that your exam is on the 27th, which is Friday. Best believe, say, you mark in the papers there. And my aim is Friday. My aim is, oh yes, and it's going to be done on Editversoft, so I'll have access to the paper at the same time. So my aim is by Monday, I am going to be posting those grades. It's a worst like home. Everybody finished off then. Oh, hear me out now. Hear me out and hear me out well. By Monday, I want to get out your grades early. So you do your exam Friday. I can post your grades and release your grades to you by Monday. But everybody has to complete your Editversoft, because if the Editversoft don't complete and I post those grades, those people are going to have failing grades on Edico. And I'm not waiting until no long time, because you have access to Edico for quite a while. So please make sure that by the 27th, is what so nice to know. Make sure that by the 27th, you guys complete every bit of it, because when I put in, I set up your Editversoft already. If you look online, you'll see your coursework grade and CAPE students, you see your SBA grades. I set up everything online already. The only thing that is missing for the CAPE students is for them to complete the rest of the work. The only thing that is missing for you is to complete the rest of the work and for me to put on the exam grade. I'm telling you, it's about time Monday morning come, business calculus will be behind me. And then I'm looking forward to the summer semester, whichever course I'm teaching. Well, I know what course I'm teaching already. And then I'm going to just move on from there. All right, let's go. So,
sir.
Yes, honey.
Remember to send this that we're doing now in the group.
Yeah, man. Absolutely.
Right.
Final class, I have to send it. And as soon as the recording becomes available for this class also, I'll also post it. Yeah, man. Let's go. So now, as I said before, I have other questions that I can give you. I have many other questions to give you. Don't have to worry. You see what, sir, did? Additional practice. Many questions that I have here. But I'm not going to go through those in class. When I send it, as DD asked, Uno can go ahead and do it. All right? What I'm interested in doing now is to do a stationary point question, because this is where the stationary point comes in. And this is where we're going to end the class. And since 11 o'clock, so you have to promise me that you're going to catch this thing in about 15 minutes. Stationary point. We know stationary points already. We differentiate the function. We set the function equals to 0. The first derivative equals to 0. It's no different from the single variable function. So we're differentiating the function f of xy to obtain f subscript x, f subscript y. Okay, so why would they have to do that? When we do that, we're going to set the differential equals to 0. And then solve the unknown simultaneously or otherwise. So it comes back to the same, something like what we normally do before. In one of them areas that we did, right? So simultaneous, and then we're going to look at the results of our stationary points. Either it's a maximum, minimum, whatever it is. But look here, D, why do I have this? Oh, to classify, D is of AB is going to be equal to f of x AB times f of y minus f of xy AB all squared. So what is AB? The critical point. AB is the critical point. So I'm going to substitute the critical point into f of x, then I've times it by f of y, then I'm going to subtract it from f of xy all squared. All right? And then that will give me, if D is positive, it's one of two things. I have to check to see the value of f of x. If D is positive and f of x is also positive, then we have a minimum. If D is positive but f of x is negative, we have a maximum. And if D is less than 0, we have a saddle point. If D equals 0, bring back the question again because we have to use other techniques to solve the critical points. So if D positive, we just have to check f of x to see if it's positive. If f of x is positive, then what we do, we just go ahead and say relative minimum. If f of x is negative, then we say relative maximum. And once D is less than 0, we have a saddle point. Those are data that you need to know. What I want to do, I will explain that last part for you. I don't want you to worry about that. What I want you to do for me is this. F of xy and this function, what I want you to do for me now is to find f of find the 6 things. F subscript x, y, x, y, x. Find those 6 things for me and then I'll now move you into. You recognize what Sir is doing? Every time you do this stuff, Sir is building on some information. So you know how to do the first 6 pieces. Your first order partial derivative, your second order partial derivative, and your cross order partial derivative. Now we're doing the last piece of the topic, and it's just classify the nature of this point. So I'm giving about 5 minutes again to just finish those differentials. Matter of fact, about 3 minutes, because this one easier. So start from me, please. On the mark, get set, go. Who agrees with me?
Yes, sir.
Yes, sir.
Yeah, man. It's how
Yes,
easy it is.
sir.
DD, it's how easy it is.
Yes, sir.
So Kate, this is what I expect them to give you, Kate, because they don't give a lot of marks for the Cape students with this. I mean, the business calculus students know you only get about 20 marks to that question. Of course, the function may be a little bit more and the differentials may be a little bit, but the concepts will be the same, right? So Cape business calculus, you may end up with a 20-mark question on it if they give you this one, or they can give you the the single variable function to work also, right? So so Kate, I would expect that the function that they're going to give you will be one similar to this one here, where the differentiation is so much easier. All right. Let me just explain something quickly before I give you one to do for me, because the topic really finished now. Watch me. For stationary point, we're going to let the first derivative equals to 0. Remember, we're going to set dy by dx equals to 0, which is really f subscript x. And we also have another one, which is f subscript y. Remember now, when we're doing the multivariable functions, we're going to have two of them to set equals to 0. So this here going to be equals to 0, that going to be equals to 0, and then guess what? The only way to work them two, we have two equations with two unknowns, simultaneous equation. So we have two equations in two unknowns. Hint, what's that hint? Hint, hint, solving simultaneously. Right? So anytime I have two equations, two unknowns, we're solving simultaneously. Every single time. Every single time. All right, let's go. So I'm putting my two equations equals to 0, and then I'm solving simultaneously. Now I'm using the elimination method. Right? Using the elimination method. So look at what it is. I want to eliminate my x's. So you notice that this is a 2x in the first one, and down here is a 3x. So when I cross multiply the coefficients of the x's, I'm going to multiply this first equation by this x down here, 3, and I'm going to multiply this first equation by this 3 down here. So why did you do that? So that when I do the multiplication, I'll get both of them to be the same. All right, and then I can subtract. And when I subtract, I'm going to have, using 6x minus 6x is 0, 9y minus 4y is 5y, and 0 minus 0 is 0. So y is equal to 0. And then I'm going to put y equals 0 into the function. I'm going to get x equals 0. Let me see something here. I'm going to get x equals 0. And those are my critical points. I'm not interested in showing you the last part just yet. Take a minute or two to look on this first and go through this on your own, and I'll come back to you. I'm stepping away for 2 seconds. All right. Are there any questions with simultaneous equations?
No, sir.
No, sir.
Wait, is there any way to identify, like, if they give you a question, is there any way to identify that you're supposed to solve it in a simultaneous equation?
Yeah, man, I did say it. Let me show you what I wrote. We have two equations and two unknowns. Hint, hint, solve simultaneously.
Yes, as long as them asking for like stationary point, you have to go solve simultaneously.
More than likely it's going to be simultaneous. Yes, honey. More than likely it's going to be simultaneous. And then like 90% of the time it's going to be simultaneous. But guess what? You have some simultaneous equations where you solve by the substitution method. So you may be able to get one equation and work the equation by itself, and then, well, not really work it by itself, because that equation will be, it could be an equation in x and y, it could be an equation in only x alone or y alone, whichever it is. But, and then we substitute it into the other equation. I'll see if I can find one of those to do, hopefully in the past paper, because I really want to do some past paper today. All right, so very nice. So we'll get the stationary point to be 0, 0. We're going to substitute that into the formula. Watch me. This is the formula. D of AB, remember AB is just simply this critical point. So my AB in this case is going to be 0, 0. See it here, so? My AB right here says 0, 0. So I'm going to be looking at my f of xx now. But hold on, sir. Your f of xx was, why didn't I not do that? I normally do to know. Oh, see it here. I was about to say I normally copy the thing instead of having to go back. So this is what my f of xx was. My f of xx is 2. My f of yy is also 2. My f of xy is 3. And my f of yx is 3. But sir, why have to use both of them and then just ask for f of xy? Yeah. But guess what? Even though they ask for f of xy, listen to your teacher. Never try to just evaluate one of them. Evaluate both of them, because when you evaluate both of them, they both will tell you if you're on the right track. Listen to me now. Some students will just go ahead and just differentiate f of xy or f of yx, and something go wrong in another question, and then can't pick up an error, and then come out and say, yeah, me get 20 out of 20, where the error could have taken place out early. See? That just seen it a while ago. Thanks to my niece or my nephew. Steal up. All right, let's go. So this is my function. What I'm going to be doing here is to substitute. It says f of x, xab, but sir, I don't have any variables to substitute into it. No, you don't. So you're just going to say this is 2 times 2, which is 4. See the 4 right here. So minus this 3 squares, and 3 squares is 9. So 4 minus 9 is a negative 5. The mere fact that d, the value of d is negative, it gives a saddle point. The mere fact that d is negative, it gives a saddle point. If d were positive, then we have to look at the f of xx value. And if the f of xx value is positive, we have a relative minimum. If f of xx is negative, we have a relative maximum. That's all it is saying. Question. Are there any questions?
Yes, would have been useful. This information would have been useful for medical staff, sir.
No problem. And guess what? One of the things that I pride myself in, and this is all secret. So if you notice what I have done for some of you, you would have moved on, and like there's one student, won't call the name of the student, who went on and got 100 in most of them, and like in 3 of them, the student got 75 and 83% and support. I know what sir did? I reopened the 75 and the 83. So Laura, you don't have to worry. If you want to complete the work on EducaSoft in time and I check it, if you're the ones that you never get bills for, I have no problem reopening them, so they can read it to get no bills. But I can only do that for students who complete the assignment. Because if you don't complete the assignment, and guess what? I am not going to, if you only complete 3, and the 3 of them get less than 70%, I'm not opening those. You have to reach a certain place in the assessments before I can say, okay, let me give you an opportunity to improve on that. I'm not going to do that, because you spend time on that one when you have many more to do. So if you're almost finished or finished, I'll go through, and I've done the same thing for the case students. Matter of fact, it just brings my attention to this. One of the Cape students says something in the chat to say, sir, why has my grade changed on Edicosop? And I never get around to read. No, it's not that I'm talking about it, I remember. Because I would have gone through, I would have seen some very low grades and reopened them. So when I reopen them, the grades will change until the complete assessment finally. All right? So those of you who really want the opportunity to get the 20 out of 20, and I keep telling people, I don't ask students to like me, because my true self, my Bible says that my life is supposed to be my testimony. My true self comes out. I am for the students. And if I can play around with 20%, which is my Edicosop work, I'm giving you the opportunity to do well. So if I see that you can get a higher grade, I'm going to reopen the assessment. But if you don't do the assessment, I can't reopen it. I'm sorry, that's also honest truth. And I can only speak the truth because that's what God loves. So I'm going to complete something now. Complete something. And Cape students, it goes for you too, because I had to submit some grades the other day. As a matter of fact, I'm submitting some other grades for you on Monday. Not Monday. Yeah, Monday. No, Tuesday. I submitted those grades on Tuesday. I submitted the SBA grades on Monday, but I submitted the other grades on Tuesday. Complete the stuff. Because the truth is, whether or not you get a distinction for the Cape Math, you're going to other institutions for something, and you want to move on to foreign or whatever, they come back to the institution and ask for a transcript. And that's what a lot of students do recognize. Quick story. My wife would have left high school long time. And she got a new job a couple years ago. I know what she had to do. She had to go back. She could find something and to go back to CXC. And this is somebody who has a second degree. Had to go back to CXC to get her copy of her CXC results. She had to go to sister so sister can write a recommendation for her. And when sister write the recommendation, she had to go and get recommendation from her first degree, transfer from her first degree, transfer from her second degree, and etc. etc. And I'm saying to myself, but why do I go all back again something here? Suppose you were a bad student and you improve over time. But the organization, based on the job that she does, the organization wants to see what type of character this person comes to the table with. And I'm saying to you, the footprints that you leave in the sand sometimes can make you or break you. I'm just saying. All right, let's go. So very good that you understand what is happening here.
Sir, also yes, before you continue, in high school I used to like simultaneous equation, but again.
And the other part of that story is, you see, unforgiveness is not a good thing. You have, Laura, listen to me, Hey, like this funny going on, Laura, that in everything in life we can associate it to how God wants us to do the stuff. Because I'm telling you, it happens to me too, It happens to me. I was saying to my Cape students, and they're right here, they can tell you. I remember doing an exam once and I got 96%. You know what failed me? Surds. Because I hated it something. I mean, when teacher teaches, I said to myself, I don't need to learn that. And I never learned it. And while it was on the exam, I got one question wrong for 4 marks. And it was it's a surds. And the teacher chanted me and I said to myself, learn this. And when I had to learn it, when I became a teacher and I had to teach it, and I recognized as Cape students, there's nothing difficult in surds, but I had a mind block. So when we have unforgiveness in mathematics, it comes back to haunt us, and we have to pray for forgiveness and confess and learn it. Amen. Anyway, come here, honey. You'll catch it, man. Never mind. All right, let's go. I'm giving you one one more. One more. Let me see now. Bam, 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 bam. Okay, I'm going to give you this one, and then I'm going to give you the others for other pieces of work. All right, so I'm giving you that one, and then we're going to pause. Please, I'm giving you 5 minutes to do this because I really want to spend a half an hour. I wanted an hour, but I want to spend a half an hour to do some past papers. All right, so 5 minutes to do this one, please. Thanks. All right, so what I have done is to, don't know if you are watching the screen, but what I have done was to post the f of x, f of xx, f of y, f of yy, and the cross order partial derivatives. Are you in agreement with all of those?
Yes, sir.
Yes,
Great
sir.
job, great job. Let us do, I wanted to just work through this one with you. That's why I didn't, oh, hi. Yeah, I wanted to work this one with you. So I no need to, and why I gave you this one is because this one now for f of xx and f of yy, they have variables for which we need to substitute. So what we're going to be doing is to solve these equations simultaneously. Lord have mercy. The one that don't look nice. So we're going to put this first derivative equals 0. This first derivative here equals 0. So we have these two equations now, and we need to solve simultaneously. See them there? 3x squared plus 3y squared equals 15. 3y squared plus 6xy equals 15. What are we going to be doing? We're going to be solving simultaneously. I decided that I'm dividing through equation 1 by 3. I'm dividing through equation 1 by 3 so that the equation becomes a little simpler or easier to manipulate. So you have to divide it by 3. No, you don't. But I work smart and not hard. So when I divide through by 3, I'm going to get x squared plus y squared equals 5, right? When I rearrange that equation, go ahead, Laura.
So you just choose the number, sir, by observation?
Yeah, because I recognize that 3 is a factor of 3, and 3 is a factor. So I look at what I can divide through that is a factor of all the terms.
Okay.
Yeah, man, that's all I do. Just look at it, that factors of all the terms, and then and just go through and just do this stuff. Follow me? Laura, are you with me? No. All right.
Sir, yes, sir, I was writing.
Oh, okay, all right. Yeah, man. So that's what we do in order to get this solved. So we're going to solve simultaneously now. So when we solve simultaneously, it has to be a method by substitution. Why? Because I can't use elimination to solve this equation because both equations are nonlinear. Both equations are nonlinear. So I have to, here's a God why I'm doing this one now, based on the question that Laura asked earlier. It's nonlinear. How do you know it's nonlinear, sir? Because I have a square term in it. You notice one equation has 2 square terms and the other equation has just 1 square term. So it's not a linear equation. So when I'm solving my simultaneous equation, if the equations are not linear, if both equations are linear, like the first question was, I had something like 3x plus 2y equals something equals 0, and then I have 2x plus 3y equals 0. Those are 2 linear equations because the highest power in them was raised to 1. In this one here, the equations are nonlinear. Why? Because both equations have a power greater than 1. Yeah? Both equations have x squared something. So it's 2 nonlinear equations, right? 2 nonlinear equations. So what we do here is that I have to substitute. I cannot use the elimination method. I must substitute. I have to substitute. There's no way I can solve this question by eliminating. So what I'm doing, why I work that equation the way I worked it in terms of dividing through by 3, so as to give me a nicer front to work with. All right, so I'm going to have y squared is equal to, what did I say? Y squared is equal to 5 minus x squared. Y squared is equal to 5 minus x squared. And so why you have to start with y? You couldn't start with x. I could have said x squared is equal to 5 minus y squared. All right, so I can choose my x's or my y's. It doesn't matter which one of them I work with first. It really doesn't matter which of them I work with first. Right? So I'm choosing which one. And guess what? If Laura decides to work with x first and then Diana decides to work with y first, guess what? Once I'm working correctly, the pair of them will get the same number of marks. I promise you. I promise you, promise you, promise you, promise you, promise you. All right? So what is going to happen now? Look, I'm going to, and I know why I did that. I think I was trying to bring across a point with that question. I actually stopped doing the question because I buck up into something that I didn't want. I don't think any of the examining bodies will give you, right? I don't think any of the examining bodies, so that's why I stopped it right there. So I would have to find the square root, no, because I don't have anything for y squared, so I will have to go ahead and find the square root of y squared to give me y equals 5 minus x squared, the root of 5 minus x squared, and then I will substitute into the function. So that function is solvable. It's solvable, but I am not going to go through a question like that because the level of questioning on your exam, CCCJ or K, they're not going to give that question like that, I guarantee you. No, for the other courses that I'm teaching, like the Calculus 2 course, a question like this I can give to them because they do, you know, a little bit more than what you guys are doing. So I could give them something like this, but for you, nah, I'll stop it right here. I'm not going to overkill you so that, you know, nah, stop it right here. All right? Okay. Are there any questions? But just for you to get the gist of it, that yes, you will get the point I was trying to do when I was creating this question is to show you that sometimes you won't always get the question where you don't have anything to substitute for the values of x and y when you're trying to classify the function, the critical points, right? You will get other things. There is a question I think I have. I think I've given the team students a question. Let me see if I can find it here. See if I can find it right here. So yeah, so I'm not going any further with that. Oh yeah, so look at this question here now, and I will just work through this one very quickly too. You don't need to write because I'm going to send you the document. F of x, y is equal to all of that. We're finding f of x. So those of you who didn't get it, let's start work this one now. This is my question. So I'm finding f subscript x, and tell me if I am going wrong. F subscript x. So I'm not dividing, I'm differentiating with respect to x. So this will become 4x, see it right here. So this is a constant, it goes to 0. I'm differentiating with respect to x. So this is negative 2y right here. So differentiating with respect to x, that becomes 5. That's 0, that's 0. My xx, this 0, so I left it 4. My f subscript y, this goes to 0, this is 2y, see it right here. So differentiating with respect to y, differential of y is 1. 1 times negative 2x is negative 2x. Boom. Differential of y, that's 0. Differential of y is negative 3, constant 0. I have those two. When I differentiate this with respect to y again, that goes to 0, so does this one. So I'm just going to have 2. And then when I differentiate x with respect to y, x with respect to y is just 1y, we have negative 2. See it right here, so. And y with respect to x, I have only 1x. This goes to negative 2. So I get my 6 differentials pretty easy. And then now remember, I'm solving simultaneously my f of x and my f of y. So I'm going to set those equals to 0. See it here, so. Bam, I have 2 equations in 2 unknowns simultaneous. So when I solve it simultaneously, if I multiply this piece here by 2, I'm going to get all of that goes, and 2y plus 2y is just going to give me 2, and 6 plus 1 is 1. Right, so I'm going to have x equals 1. And then, and you'll get more time to look at it. I'm just going through this quickly. And I will put x equals negative 1 into any of the 2 equations, and then I'm going to get y equals to a half. So my critical point is going to be negative 1 comma half. Substituting that into the function, and there's nothing to substitute into the function because I don't have any variables for f of xx or f of yy. So when I multiply f of xx, which is 4, by f of yy, which is 2, I'm going to get 8. Minus negative 2 squares is going to be 4. So I'm going to get something that is positive. So because it's positive, it's going to be either a relative maximum or a relative minimum. In order to differentiate the two, I must look at my f of xx. If my f of xx is positive, then I have a relative minimum. If my f of xx is positive, then I have a relative minimum. Let me just copy this here. Copy. Oh no, geez, undo. Copy. Let me just copy that, put it down here. So, oh boy, as I write this, RECALL. You know, but I was telling you about my past students that I saw last week, Thursday, and trust me, they put a smile on my face. I was there talking to these students, and one of the girls said, "Are we serious in the class again?" And one of them bawled out, "Recall!" I say, "Oh no, don't say good." But yes, man, recall. My students, so they have done very well in their final lap. Proud of them, man. Those are my babies. So all this in class recall. I say, yep, good to go. All right. So my f of no, but I need to also do the f of x y here too. Anybody found a past paper? Any past paper at all? No? Yeah? Yes, not. All right. So my f of x, there is no variable to substitute, so I just put in the 4. My f of y, there is no variable to substitute, the negative 1 comma half, so I'm just going to put the 2. And my f of xy, my f of xy is the same thing as my f of yx. So, sir, why you have xy here, but you have yx? Deliberately done a while ago. Deliberately done a while ago. And that's why I'm saying these two are always the same, so it doesn't matter which of them I use. All right? But these are 6y, but my y value is a half. What is this? Something's not right here, sir. Something right. My f of xy was, something's not right. My f of xy was what? My f of xy, no, I copied the wrong thing. My f of xy is 2. Yeah, my f of xy is negative 2. So why did I copy this to be 6? Where did I get 6 from? 6y from? Oh, I copied it from up this question here. My bad. My bad. My bad. It's supposed to be negative 2. I apologize. So it's going to be negative 2 all squares. And negative 2 all squares is 4, so we have 8 minus 4. And then 8 minus 4, you notice I'm not interested in positive 4, but just going to say greater than 0, right? So because it's greater than 0, it means that it's positive. And because it's positive, what I now need to do is to look at my f of xx. Well, my f of xx is also positive, so I have a relative minimum. So since f of xx is greater than 0, then I'm going to have a relative minimum at the point negative 1 comma half. A question like this is what I expect the CAPE students to get. It's not a long, prolonged question, and CAPE students, you can get about 10 marks for this. Business Cal, I would expect you to get a question similar to this, and they may give you a little bit more than 12 marks. I mean 10 marks. They may give about 15 marks for this. All right, but yeah, man, this is it. Done. Finito. 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 Any questions?
No, sir.
All right. So my thing is, nobody has even one copy of a business calculus past paper. Not even one copy. So we can't even do one piece of a question. No, hear me out. My kids students are working past paper questions in business calculus. There is no way you can come through university without working past papers. So if you've never worked in past papers, don't make it happen from second semester 3 next semester. You have to have past papers right at your fingertips. All right? I don't have any at hand. I mean, the ones that I would have, I would incorporate it in my document when I am doing questions. I'll just find a past paper question and just fling it in there. But all right. Okay, not going to point. How you feel, business calculus? How you feel? Are you feeling ready?
So ready minus the other 2 ready.
And that's fine. That's perfectly fine. That's perfectly fine. Kate, how you feel? And know, Kate, that you're working because I see the questions coming to the pool. I see the questions coming in, so I know you're working. Even though no rush me, so maybe late by 2 hours. But I see the questions coming. but love it. Love the energy. What I also love is that, you know, when they post a question and answer, never respond immediately. Like I did the first question. They say, oh, they never rush me when you drop the question, and I was up and I saw the question and I said, no, grab paper and pencil and do it. Yeah, and never rush me them times. But, you know, I'm happy that there are students in the class who can work the question. And basically what the CAPE students are doing when they're working the past papers and then book up into something that they don't know what to do, then just drop it in the group. Teacher or otherwise will work the question and, you know, have an explanation. So then they kind of rush the data. Then they put something in there and they answer them immediately. And say, sir, you're late. Just like, sir, you're late. We got the answer ready. Save your energy until you find something that we don't know how to do, but you love on the same way. Any concerns? Any concerns? Any questions?
Sir, we have that purple right in there. Is that at times?
Yeah, man, the multiplication sign, yeah. But
Okay,
I don't know. I don't know why is it that I use such a big one. Oh. Yeah, so it's a multiplication sign. All right, let me tell you how I feel. Since we don't want it in a half 5 minutes, let me tell you how I feel. So at times, I kind of get a little off with the business card because when they not talk to me, but it didn't change the love, teacher-student love. Didn't change it, but I just have to tell you, in a relationship, you have to tell you, you have disagreements again. I was a little annoyed last week because people were here but were not here. Some weren't here physically, but some were present and not present. But I understood why. But that is just one or two incidents that happened in the semester. But for the most part, you guys turned up. Some of it kind of overslept, you know, week in, week out. But for the most part, this is a positive note. For the most part, you guys have done well. I can truly say that you guys have learned. I've marked the mid-semester. I'm seeing your level of mathematical maturity, you know, develop in a way that I am so very pleased about and pleased with. And for that, I just want to say congratulations. We have done what it is that we're supposed to be doing. As I speak to you, there's a wonderful thing that comes to mind that I need to do. And you know what I'm going to do? I'm going to do a voiceover on a document and send out to you so you can listen to it and we can have a conversation in the WhatsApp group about it. And I'll share the same voice, the same thing with the CAPE students. Just something that comes to mind, and I'm saying, let me just do one or two questions and then just send it out to you. We have covered the stuff, and I'm expecting you guys to do pretty well. I'm expecting to do pretty well. You know, the CAPE students, this calculus will tell you that we were under pressure. God has been good to us. He gave us 3 weeks extension. We were working on our SBA. We never started our SBA until very late in the game because I needed to go through some statistics to the point where, as they know, I was able to take my time and go through units 1 and units 3, units 1 and 3. You know, gently and build up and spend a little time. The unit 2, which is a statistics unit, I only had to rush through it. And they know my level of discomfort because I was able to spend a lot of time with them on that. True for CAPE students?
True.
Right. But did I spend enough time with you on unit 1 and unit 3?
Yes, sir.
Yeah, man. So, and they understand. You know why they understand? It's not that because, sir, from a class I never teach. Time was so short, and they know they have to miss some of these classes, teaching sessions to do SBAs. But you know, the SBAs kind of taught us a little bit more too. So one of the things I keep saying to them, every time I send a message out to them, do your EducaSoft, but focus on the statistics first, seeing that we never get the time, the intimate time to spend on the statistics, right? So one of the things that I want you to learn about me, I don't want any of you to tell me my shortcomings. I already know them. You can reinforce them and say, boy, sir, you know, in all of that, you know, We did well on the unit 1 and the unit 3 because it takes the time, and then sir, you invited us to the business calculus class, and we're able to work together with the stuff, and we finish off them something. But there was just one little teeny bit. Oh, and there's one little teeny bit something that when I meet you guys, Cape students, I need to go through with you. I just didn't do it because the time was was concerning. But guess what? I am not alone. The other teacher was in another pickle himself. But what I'm giving God thanks for is that I remember one Friday we started our SBA. I'll make this Saturday, I'll make this Sunday, and within a week we'll finish off the stuff. And the other week or two we use that time to just finish the stuff. And I mean the papers were marked. And they all did well. They all got over 50 out of 60. All right? Over 50 out of 60. And they did pretty well. I am pleased with what it is that I saw. There was one of the SBA that I read, and I could see the level of maturity coming out of it among the students. So in all, I think collectively, business calculus, Cape students, I think we worked pretty nicely together. And my prayer now is that you guys will do very well. And I have about a minute and a half. I don't know where your spiritual level is, but if you will just permit me to just pray with you, to just see all that we have done for this semester, I would love it if I could do that. Am I allowed to?
Yes, sir. Yes, sir.
Okay.
Yes,
So
sir.
let us thank you. So let us pray. Father God, we come before you. Thanking you for who you are and whose we are in you. Father, we know that we have not done the things that you've asked us to do. And the things that you've asked us to do, dear Lord and Father, we've left them undone. How cruel of us, how unnice of us, how unchristian of us. But Father, you said to us that if we confess our sins to you, you will be faithful and just to forgive us of all our sins and to cleanse us from all unrighteousness. And Father, we are confessing that we have not studied hard and long enough. We confess, Lord, that we have not done or assigned tasks. Father, we confess that we are procrastinating. But Father, we ask that you will show us mercy. Because your words remind us in John that if we confess our sins to you, that you will be more than faithful and just forgive us of all our sins and to cleanse us of all unrighteousness. So Father, we confess that we have not done and be the students that you want us to be. But Father, we ask for favor. We ask for favor, Lord. And the favor we ask for is that you will lead us into a path, not only of righteousness for your name's sake, but a path, Lord, that will cause us to be guided so much in doing the questions and prepare ourselves for what is on that exam paper. Father, we pray for divine intervention and spiritual leading, that Father, you'll say, focus on limits and focus on stationary points and focus on that. And when we so listen to that soft still voice that speak to and through us, that Father God, we will do what it is, and Father, we know that it is you that is speaking to us. So Lord, when we go into the exam, we can reproduce. Father, I pray that the both examination papers will be in favor, one on Monday, one on Friday. And Father, I pray that you just cover each and every one of my students, from the very corner of their heads to the very sole of their feet. Father, I pray that you will be with me the lecture, because Lord and Father, I know that I'm going to have butterflies and diarrhea on Monday when my students are doing their exams. And Father, I know I'm going to have diarrhea and butterflies on Friday again now when my business class students will be doing exams. But Father, I pray that the peace that passes all understanding will just be with us in a way, Lord, that will calm our spirits. Father, I pray for success. I pray for revelation as we do the exam paper. I pray, Lord and Father, even more by extension, that you place your blood over our doorposts, Lord, that when the devil comes in a physical form, comes in a spiritual form, or even come to attack us to say that we never pass the exam, that Father, we can resist the devil and he will flee from us. We can trample upon him and upon his kingdom and say, move away from us. So we thank you, Lord, for what you are going to do, because Father, I am confident that you will cause these all my students to be very successful. Father, I pray that you will take care of their financial needs, their emotional needs, their spiritual needs, their relationship needs, their education. Father, God, everything about them that you will take care of. Father, I pray, Lord, that you will just even now cause for them over this weekend to just be relaxed. And especially, Lord, my Cape students, Lord, who on Labor Day will be laboring. Father, I remember when I was doing my CXCs, my chemistry exam was on Labor Day and I was very nervous. But Father God, I came out extremely successful in that exam. And I pray, Lord and Father, that the same favor that you bestowed upon me many years ago, that you cause to fall upon them and upon my business students. I thank you. I thank you, Lord. And I just ask that as the hours pass and other things come to mind, as you speak to me also, that Father, you give me the strength to just go and prepare and to send some information to them so that they can go and do their final prayers. I thank you, Lord. Thank you for this opportunity again, and ask that you just be with us in a very special way. Father, we pray this in Jesus' name. Thank you, Lord, and amen.
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 All right. Bless you, bless you. Team students, you'll hear from me soon. I think, can I rest off the week and we'll just talk about some other stuff? This girl, you'll also hear from me. As I said, something just came to mind, and I'm going to just drop it in a voice over, and then we can just do this stuff. But all the best. I'll send you the notes, and as soon as the recording becomes available, I will send it off also. All right?
Okay, sir.
Okay, bye, sir.
Yes, sir. Thank you,
Bye-bye.
sir.
Bye, sir.